So clearly this is a polynomial, and a polynomial that I can easily factorize a little bit. Okay, so not with a nice number, but that's okay. So we've got an x cubed, we've got a difference of 2 squares. Alright, so you can see pretty quickly that there x equals 0 gives you a point of intercept, an x-intercept, but so does root 15 plus and minus root 15. So we know at least, and it's to the power of 5, so we know kind of what's happening there. So it looks like it's an odd function, and you can see if I sub in negative x into that, I'm going to get negative f of x. So yes, it's also an odd function, which is handy to remember. So whatever's happening on one side is going to reflect in a rotational 180 degree symmetry on the other side. So all right, so we know those, and we can go ahead and find y dash maybe will help us. So 5x to the 4 minus 15, 30, 45 x squared. And let's just put 5x squared outside of that. Am I doing that right? Right. Yeah, I think so. Alright, so something like that. And so again, you can see we've got difference of 2 squares. So what does that tell us? Well, when y dash equals 0, we get the stationary point. So we can see we're going to get a stationary point at 0, at 3, and at negative 3. They're our stationary points that we're looking at. So if we just quickly sub those in, we can see into our f of x, we can see 0, 0 is going to be a stationary point. Now, if I sub 3 in, I'll need my calculator. So let's do that. So we get negative 162. And when we sub negative 3 in, of course, this is an odd function, so that should be 162 there. All right, so we know that these are going to be our turning points, so I'm just going to put them in here. So let's say that's 3. Then my minus 3 is going to be here, where that is 162, and this is negative 162. And I go through 0, 0, and I've got a root 15 and a 15. So let's say this is a root 15, this is a minus root 15, root 15, there we go. So you can see what's going to happen here without to sketch the curve showing the x-intercept, stationary points. Okay, so it also wants us to show points of inflection. It's pretty clear how that's going to occur. First of all, if we did, because it's a nice curve, we can easily do y double dash. Yeah, so you might want to set your work out. Some people, I should start setting it out much nicer, shouldn't I? But often y, so if you do y double dash, y dash, y double dash, and you set it all up, and then you start saying, all right, stationary points occur when y dash equals 0, and you're really showing you're working like that. That would be important if this was, you know, worth 4 marks or something like that. Here, if I'm just assuming it's a couple marks and it says sketch, including these things, this is what I'm going to do. So sorry, where was I up to? My double dash being here. So here's my double dash, and I could factorize by a 10x, and I'll get a 2x squared minus a 9 here. So clearly we can see that at x equals 0, there is a possible point of inflection there, and we know it's a possible point of horizontal inflection because y dash of 0 gave us equals 0, gave us a stationary point as well. So if we just check either side of 0, for example, 1 and minus 1, so if I put negative 1 in here, you can see it's going to be a positive, sorry, a negative for negative 1. And then in that bracket, it's going to also be a negative. So it's going to start with a positive on the left-hand side. So it's part of a happy curve on the left-hand side. If I go to the right, so I'm putting a positive 1 in here, that would be a positive, 10 times 1 is a positive, and then 2 times 1 minus 9 would be a negative. So I'm going to get a negative. So it's going to be part of an unhappy curve. So if you think of it, so it's going to be part of a happy curve, and then part of an unhappy curve. So it's a point of horizontal inflection. So that at 0, there's a gradient of 0. So it's a point of horizontal inflection there. And then I know that down here it must go like this because it has to cut through there. And remember, I also know it's an odd function. So over here it's going to cut through, where did we say here? So it's going to go, and it's got to go through there. So the other points of inflection, yes. Clearly, if it's going, you know, unhappy here, happy here, that there is a point of inflection somewhere there. Same here, it's unhappy, and then clearly happy here, so there's a point of inflection somewhere here as well. So from my y double dash that I just rubbed out, what was it? It was a 2x squared minus 9, I think. Something like that, I think. In that, there was a 10x, wasn't it? So anyway, in this second bracket, we're going to get a root 2x minus 3 and then a root 2x plus 3. So you can see from both these brackets, you're going to get plus or minus 3 on root 2. Is that right? 3 on root 2? I think that's what it was. Now, if I multiply by root 2 on root 2, what do I get? I get 3 root 2 on 2. Alright, I better check my y double dash for you properly. And so let me just... Yes, sorry about that. Just because I'm not sure if that was correct, if my memory is correct or not. So let's go back to this. My y double dash would be 20x cubed minus 90x, if I got that right. So 5x to the 4 minus 45x squared is correct. Alright, I think I was correct. Alright, so 10x, so 2x squared minus 9. That looks correct, doesn't it? 10x. So if I square both of these, I've got root 2x minus 3 and then root 2x plus 3. That would give me 2x squared minus 9, so that is correct. So maybe I had it correct. So 3 on root 2 being so this inflection point would be 3 on root 2, and this one here would be negative 3 on root 2. And then, of course, we could also sub that into our y value, which I don't know if, it wants us to find that, but really. So 3 on root 2 to the power of 5 minus 15. 3 on root 2 to the power of 3. Alright, it's going to take me too much work. So anyway, you can do that in your calculator for me. But hopefully you get a negative when you put 3 on root 2 in, and you get a positive when you put negative 3 on root 2. So there are your points of inflection, your x-intercepts, and this one, of course, being your horizontal point of inflection. We could have put this point 3 into double dash, and you would hopefully get a positive answer. Actually, you could just do it here. So if I put 3 in there, I get a positive there. I also get a positive here, So that's happy, part of a happy curve. So that means it's a minimum stationary point, which it is. If I put -3 in, I'm looking to get a unhappy curve. So let's have a look. -3 would be negative here, but positive here, negative times positive, negative. So yep, that would work too. So there's all these different tools you can use, but really, once you've got a couple of points, it's probably quite obvious what the curve looks like. And then I just have to go back and see what it asked me to do. It says showing the x-intercepts, stationary points, and the points of inflection. So you've got to make sure you find those as well.